Hello everyone, my name is Kareem Darwish. I'm a principal scientist at the Qatar Computing Research Institute, and I'm going to be talking to you today about unsupervised stance detection. So let's get going. So let me start by giving you a background about what stance detection is. And basically what stance detection does, it tries to find the position of a user towards an issue or an entity. So in the example that I have here, I have two people who are of opposing views on gun control and two other people who have opposing views about statement that was done by Ilhan Omar, who's a representative in the US Congress. And I want to point out that stance detection is not sentiment analysis. So you can actually have positive stance with negative sentiment. So if somebody says, I feel bad for you, basically that's positive stance but negative sentiment towards you. Or you can have the exact opposite. So if somebody says, I'm glad that he bought the farm, and buying the farm means that the person died, that actually has positive sentiment, but actually negative stance towards the person. And the nice thing about stance is that stance is fairly durable over a long period of time. So people who are Barcelona fans continue to be Barcelona fans for months or perhaps years and rarely ever switch. And people who are Republican continue to be Republican and rarely switch, and vice versa. And stance detection can be really helpful for many applications, like for example, doing polling, doing marketing, figuring out what subgroups constitute people who actually support or oppose a particular topic. And this can be helpful for telling or crafting messages towards them, finding people preferences, and so on and so forth. And since stance is affected by our environment, about how we think and the people we interact with, it can be informed a lot by social psychology. Specifically, we know that people congregate around people that are like each other, and this is called homophily. And the old adage goes that birds of feather flock together. And once people are in groups, they start influencing each other or pressuring each other to say certain things or act or behave in certain ways. Even if it's an impromptu gathering. For example, you're walking down the street and you see people looking up, and the natural instinct of people because of social pressure to actually look up also. Now, once people congregate into groups because they are like each other, and they start being influenced by each other, so they start forming things called echo chambers, where basically they're close communities that kind of tend to share socially conforming content from similar sources over time. Now, traditionally, people have done stance detection in a myriad of different ways. And perhaps the most popular form of doing stance detection is using supervised learning, where basically you go out and tag a seed list of users. You extract features like which words did they use and which accounts that they retweeted and so forth. And then you train a classifier like a support vector machine classifier or logistic regression or something else. And the nice thing about doing it this way, it's actually fairly simple. But the downside is that it requires training data and the accuracy is capped at around 90%. Another method is semi-supervised learning, where basically, again, you tag a seed list of users and then you find users who behave in very similar ways. In the sense, like if you have two users who share the same content or use the same hashtags or they retweet the same tweets, then they most likely agree with each other. And one of the more popular ways of doing this semi-supervised learning is label propagation. And the nice thing, it's accurate, it's fairly simple, but again requires training data. And God forbid, when you're doing label propagation, you label somebody incorrectly, then things can go south very, very quickly. And then comes the method that we are proposing here, which is completely unsupervised stance detection. So the idea behind our method is to construct vectors for users based on which accounts that they retweeted or which hashtags that they used and so forth. And we compute the cosine similarity between them. Then we are able to project these users into a lower dimensional space. And to project them, we can use different techniques like force-directed graphs or Tesny or UMAP or something else. Then we can do clustering over users using something like mean shift or dbScan. And somebody may ask, why are we projecting before we cluster? So it turns out that if you try to cluster people or cluster items in very high dimensional spaces, clustering generally performs fairly poorly. And we ran experiments where we try to cluster users in higher dimensional spaces and clustering fails. So how good is our method? So we ran a variety of experiments to actually figure out the answer to this question. And we used 3 different data sets. 2 of them were English and 1 of them was Turkish. The first one was concerned people who supported or opposed the nomination of Brett Kavanaugh to the US Supreme Court. The other one were people who supported or opposed Trump. And the third one were people who opposed or supported the re-election of President Erdogan to be re-elected again in 2018. And these data sets, we had ground truth for them. They were fairly large, which allowed us to do lots of interesting experiments. Like we've experimented with which feature to use, how many tweets do we actually need to get the proper unsupervised clustering, and how many users we need to cluster, and so on and so forth. And I'll show you the output of these experiments. So you have 3 seconds to actually digest all these results. 1, 2, 3, gone. Okay, so obviously the table is too complicated, but let me go through and tell you what all these results meant. So basically we had success criteria where we said, if you were doing clustering, the clusters needed to be at least 80% pure, or the precision needed to be at least 80%. And we needed to cluster at least 10% of the users. And based on these experiments that we've done, we found that the best features to use to represent users was actually which accounts that they actually retweeted. How many tweets do we actually need to get reasonable results? So if we had 100,000 tweets, purity was above 90%, and by the time we got to about 250,000 tweets for a particular topic, then purity crossed 98%. How many users do we need to cluster? So it turns out at least 500 users, and the best dimensionality reduction technique that we saw was UMAP. It was far better than TESNI. It was slightly worse than force-directed graphs, but far more efficient when you actually run it. And the best clustering technique that we found was actually mean shift. And if you look below here at the best results that we actually found, you will see that using our best setup, we're getting over 98% purity, and we were able to cluster roughly about 70% of the users. Let me show you some distinguishing features for one of our data sets. And this is the one where people actually opposed or supported Trump. And here are the most distinguishing hashtags and retweeted accounts for both groups. And we used the valence score to actually get the ranking for them. And as you can see, the group on the left is composed of Democrats, and the ones on the right are composed of Republicans. Like if you look at the Republican one, you see that they're retweeting real Donald Trump, and they're talking about fake news, and they're listening to Fox News, and the other party is listening to MSNBC, and they're using the hashtag Vote Blue to Save America. We ran extra experiments on 6 other topics for which we did not have ground truth, but were interesting nonetheless. Things like gun control, immigration, the efficacy of vaccinations and anti-vaxxers and so forth. And we clustered the most active 1,000 users per topic. And then we took a sample of users who were clustered, and then we manually annotated them, and the precision was more than 98%, and we were able to cluster more than 86% of the users. So the recall is generally reasonably high, and the accuracy or the precision is fantastic. So to recap, the best setup that we have is that you use retweets as features, use UMAP for dimensionality reduction, and mean shift for clustering, and all that is left to do is actually assign labels to the clusters, and you can actually do that by looking at just a handful of users, typically 3 or 4, and then you're able to label the entire cluster, and you no longer have to label hundreds of users to do supervised or semi-supervised learning. So in conclusion, I have one thing to tell you. Unsupervised sense detection works. So get the code from me and run it on your data set. It's simple, it's high accuracy, and there's no training data involved. Some of the limitations of this method is that it actually works when there's strong polarization between users, and it's able to find people who are very vocal in their opinions, and you have to do cluster labeling, which is not such a big problem. And as a shameless plug, we continued on work, and we used unsupervised sense detection to figure out the leaning of popular media sources and popular accounts, to figure out whether they're right-leaning or left-leaning. And we extended the method that I presented today, where instead of using retweets as features, basically we're using CNN embeddings to represent the content that the people produce, to actually do the same thing and do highly accurate unsupervised stance detection. So take a look at the papers. I think you will enjoy them, and have a wonderful rest of the conference, and have a great day.